Alright, so on to number 2 of 2010 AB free response. So, a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between noon, which is t equal to 0, and 8 p.m., t equal to 8. The number of entries in the box, t hours, after noon is modeled by a differential function, e, for from 0 to 8. Values of e of t and hundreds of entries at various times t are shown in the table above. Alright, so for part A, use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time t equals 6. Show the computations that lead to your answer. Alright, so basically the table, this is our E of t. It's asking us to find the rate. And the rate, as we know, is derivative. So and it asks us to approximate. So there's obviously no 6 on the chart. So we have to approximate between 7 and 5, or 5 and 7. As we know, in between here is 6. And so for part A, for E6, we'd be doing the slope function, which is E of 7 minus E of 5. Alright, and so we know from the table, E of 7 is 21, and E of 5 is 13 over 7 minus 5, 2. 21 minus 13 is 8 over 2. And so our answer comes out to be 400. Oh, my bad. Entries per hour, because this is the rate. Alright, Alright, so for part B, use a trapezoidal sum with 4 subintervals given by the table to approximate the value of 1 over 8, integrate from 0 to 8 of E of t, d of t. Using correct units, explain the meaning of 1 over 8, integration from 0 to 8, E of t, d of t, in terms of the number of entries. So basically, we know that our 4 subintervals are from 0 to 2, 2 to 5, 5 to 7, and 7 to 8. These are our 4. Alright, so we use the trapezoidal sum over here, 1 over 8. So we know over 8 times. So the distance between here is 2. So it would be 2 times, and it would be the distance from these, so 0 plus 4. Over 2 plus the distance from these intervals. So that's 3 times, and then angles are 13 plus 4 over 2 plus the distance between this subinterval is 2 times one's given. 21 plus 13 over 2 plus distance from 7 to 8, which is just 1, so we'll just leave that alone. Or, yeah, we'll just put in, the numbers are 23 plus 1. Over 2, because it's trapezoidal sum. All right, now we solve. So we know 0 plus 4 is 4 times 2. Get 8 over 2 plus 13 plus 4 is 17 times 3. 51 over 2 plus 21. 21 plus 13 is 34 times 2. 68 over 2 plus 23 plus 21, 44. 44 over 2. And we're solving for this. We get 171 over 2 times 1 over 8. Multiply that, you get 171 for 16, which that approximately comes out to be 10.687.5. Right, now that we solve for this, now we have to complete the next part of the problem, which is to explain the meaning of 1 over 8 integration from 0 to 8 to e of t dt in terms of the number of entries. So basically, what 1 over 8, 0 to 8, et dt is the average number of hundreds of entries in the box between noon and 8 p.m. As you can see there, that's e of t, the 100 of entries. When we integrate, when we e of t, it becomes the average we found with 0 to 8. So that's why 0 is noon, 8 is in the afternoon, 8 p.m. So that's why it's the average number, hundreds of entries in the box between noon and 8 a.m. Okay. All right, so part C is asking, at 8 p.m., volunteers began to process the entries. They processed the entries at a rate modeled by the function p, where p of t is equal to t cubed minus 30t squared plus 298t minus 900 and 76 hundredths of entries per hour from 8 to 12. According to the model, how many entries had not yet been processed by midnight that t equals 12? Okay, so basically what the problem is asking us is to find the rate from times a to 12 given by the function p of t right here. And so we're going to be, since this is a given time right here, a over here, we'll know to do 23 minus, and then as for time intervals right here from 8 to 12, we know our integrals are 8 and 12, and our function is t cubed minus 30t squared plus 298t minus 976 dt. Okay, and so basically we integrate this now, so we get t4 4 minus 10t cubed plus 149t squared minus 976t for our boundaries from 12 to 8. Let's not forget all of this is minus from 23 because that's our given time. And so from right here we plug in. So we do 12 cubed 4 minus 10 12 cubed plus 149 times 12 squared minus 976 12. And this is for the 12 part. So minus 8 to power 4 over 4 minus 10 times 8 cubed plus 149 times 8 squared minus 976 times 8 . Alright, so this basically comes out to negative 2,352 minus, and then for the 8 side comes out to negative 2,368. So these become positive. So this is added, and this becomes 16. And so with our given, write down the 23 from the given of, from the time at 8. So we know it's 23 minus 16, which gives us 700 entries, and that is our answer. That's part C. Alright, so for part D, it's asking, according to the model from part C, at what time were the entries being processed most quickly? Justify your answer. Okay, so for part C, it's, the model is talking about P of T over here. And so in order to find the entries for most quickly, we have to derive this in order to find it. So when we derive P prime of T, it equals to, 3t squared minus 60t plus 2 and 8. And so we're going to be equaling this to 0 because, oh, we have to find the change from positive to negative, or negative to positive on the graph of the model, because that indicates when there's a change. And so, since this is a calculator problem, we're just about to do that. My bad. Oh, of course. And so now we're gonna plug in derivatives. So we get 3x squared minus 60x plus 298. Okay, and so this is what the graph looks like. And so since we're equaling it to 0, we put for 0, so we second calc under 0. Okay, so our first zero, we get x equals 9.184. Then our second zero on the graph is second calc 2. So as you can see, 10.816. And so these are x is equal to 0. Alright, so now that we find out our x's, and we know that our candidates are p of 8, p of 12, p of 9.184, and p of 10.816. And so now we plug all of these into given model from C. From this we get p of 8 equals to 0, or p of 12 is equal to 8, our p of 9.0184 is equal to 5.088, and our p of 10.816 is equal to 2.911 once plugged into the function p of t. And so the question asks, at what time were the entries being processed most quickly? And so basically, based off our candidates, the one with the highest number when pushed in is p of 12. And so we know by this that the entries are being processed most quickly at time t equals 12. And that's our part D. With